All right, so this one is actually a little bit tricky. We're going to get into sequences and series. And this one is tricky because it's neither an arithmetic or a geometric sequence. And we know that because we both have multiplication and addition here. It's not just multiplying each term or adding to each term. You have a very weird sequence right here. So we can't use our standard converting from recursive to explicit form. So we're going to have to actually intuitively write things out and understand what a sequence is. So an is equal to a1 plus n minus 1. An is equal to a1 times r to the n minus 1. That's arithmetic, that's geometric, but that's all not going to work here. So actually looking the sequence, an is equal to 2 times an minus 1 plus 3. a1 is 3. So a1 is 3. a2 is 2 times the previous term. So 2 times 3 is 6, plus 3 is 9. a3 is 2 times the previous term, 9, plus 3 is 21, because 9 times 2 is 18. 18 plus 3 is 21. a4, do it in my head, it's going to be 21 times 2, which is going to be 42, plus 3, which is going to be 45. So we have an interesting pattern going on here, but let's look at what the pattern could be. Now, what I'd like to do is just evaluate the first term for our multiple choice answer choices, because we know the first term is 3, so let's plug in the first term where n is equal to 1 and see if that works out. Now, it's possible that the answer could be true for the first term, but false for the second term. So when we evaluate the first term, if both answers are 3, then we're good to go. Let's evaluate the first term. 3 times 2 to the 1 minus 1. 2 to the 1 is 2, minus 1 is 1, so that's 3 times 1, that's 3. So the first term is a potential answer. For the next one, we have 2n cubed minus 3n squared plus 8n plus 3, so that's 2 times 1 cubed is 1, so 2 minus 3 plus 8 plus 3. So 2 minus 3 is negative 1, plus 8 is 7, plus 3 is 10. 10 is not equal to 3, so that is not a valid option. Option C, 2 times n squared plus 1. Well, 1, when n is 1, the first term is 3, so n squared is 1 squared, which is 1, plus 1 is 2. 2 times 2 is 4. So for option 3, n1 is equal to 4, which is not equal to 3, that does not match the sequence. And for option D, D is 3n squared plus 8n minus 1. Well, 3 times 1 squared is just 3, plus 8 times 1 is 8. So 3 plus 8 is going to be 11, minus 1 is 10. So for option 4, a1 is 10. None of those are equal to 3 except for the first term. So just by evaluating the first term, we see that only option A can work for the first term in the sequence. So luckily, these are less tricky in that it allows you to get the right answer immediately. But this one is tricky in that you can't easily convert this into a rule because neither arithmetic nor geometric, because there's not one single rule of addition or multiplication between consecutive terms in the sequence. So that was 14. 15, a1 is 25,000. A to n to the n plus 1 is 0.8 times a to the n. So it's geometric. Each consecutive term is 0.8 times the previous term. That means r is equal to 0.8. That's the coefficient of, essentially, you multiply by 0.8 for each additional term in the sequence from the previous term. Using the formula from our formula sheet, we know that an infinite series, or infinite sequence, for a geometric term where r is less than 1, in which case it is going to be a1 over 1 minus r. So it's going to be a1, which is 25,000, over 1 minus r, which is 1 minus 0.8, which is 0.2. So 25,000 over 0.2 is the same thing as 25,000 times 5. And to validate that in your calculator, you're going to get 125,000. That's answer A. So you need to be able to recognize A1, you need to recognize R, you need to know the formula for an infinite sequence, which is on your formula sheet, so you need to find it and apply it and plug that into your calculator, or just do 25,000 times 5. That's something you can do in your head to get an answer choice A. For answer choice B, or for 16, the answer is B. Let's show you why. Okay, recognize the logistic function. The easiest and fastest way to do this is know that the logistic function has a horizontal asymptote at x equals 0 and a vertical and a horizontal asymptote at x equals its carrying capacity, and the carrying capacity is the value on the numerator. So the horizontal asymptote is going to be x equals 0, x equals 100. So as x approaches negative infinity, this lower horizontal asymptote, the limit is going to be equal to 0, and as x approaches infinity, the limit is going to be equal to 100. But let's say you don't know the logistic function. Conceptually, we can do 100 plus 1 over 1 plus 5 times 0.75 to the negative infinity power is equal to 100 times 1 plus 5 over 1 over 0.75 to infinity power is equal to 100 over 1 plus infinity. And that's going to be equal to 0. And conceptually, that's just because 1 over 0.75 to the infinity means that gets 1 over times 0.75. So that becomes a smaller and smaller decimal. So 1 over 0.000000001 is like 1 times a million, or 1 times an infinitely large number. So that means that you have an infinitely large number in the denominator. So 100 over an infinitely large number is going to be approaching 0. The limit as x approaches infinity, that's going to be 0.75 to the infinity power. So that means 0.75 each consecutive time you multiply it, raise it to a higher power. It's going to get smaller and smaller and smaller until it almost becomes 5 times 0. So that's going to be 100 over 1 plus 5 times 0 is equal to 100 over 1, which is 100. Now let's evaluate this in the way that you can evaluate all limits in your calculator. Almost. Mode, function. Let's put in this logistic function. 100 over 1 plus 5 to the 0.75 to the x power. That's a logistic function. And now we're going to find the limit. So in order to find the limit, we're going to go to table set, have the table start at x approaches a really small number. So negative infinity, so let's do like when x is 1,000, let's just do negative 99999. Find that table. We have an error. So that's not, I guess that's not the most promising, but let's look back at the 100, 100 over 1 plus 0.75 to the x power. Table set. Let's have the change in the table just be 1. Let's just do negative 100, second table. Okay, that's why. So if you pick your table value too large, the calculator can't even handle it. Even at negative 100, it's a little bit big. So let's do negative 50, see what's going on. So that's going to be 1.1 times 10 to the negative 5. So that's going to be 0.0000001. So about that level. So just that x equals negative 50. So as x approaches negative infinity, this is going to get closer and closer to 0, so the limit's going to be equal to 0. This is an infinitely small number. So the limit as x approaches negative infinity is 0. Let's find the limit as x approaches infinity. Second table set. Let's pick a very large value. So let's say x is equal to 200. Second table. As x gets larger and larger and larger, it just approaches 100 and becomes 100. So the limit as x approaches infinity is 100. So 0 and 100, that's the option. That gives you 3 ways to do this problem. Intuitively know a logistic function, intuitively plug in infinity, even though that's not technically mathematically correct, and use your calculator to evaluate the limit. That's 16. For 17, this is one where you have to know this conceptually and conceptually be able to evaluate it in your calculator. I also picked do an example algebraically, but I think it's just easier to evaluate this in the calculator. So the main function is going to be f of x is going to be equal to x squared minus k squared, and k is a constant. Let's pick an easy number for k, which is going to be 1. X squared minus 1 squared. That's the numerator. And then the denominator is going to be x minus 1. Okay? So we have that, our function, and that's going to be when x is anything except for k. So when we're approaching 1 from the left, or k from the left, we can look at values of 0.999999999 as values that are approaching k from the left, or in this case we picked 1 for a constant. So let's just choose 1. We go to table set, have our table start at 1, because we're valuing at 1, but we'll have our change in table be very small numbers, 0.0001. And then we're going to look at our table. At 1, we have an error, but it's okay, we're looking at what the limit is approaches. And as x is 0.9999, our y value is 1.999, and you can bet your bottom dollar that that means that limit is going to be approaching 2. Well, if k equals 1, 2 is equal to 2 times 1, or 2k, so our answer is B. I believe that the calculator 1 method, if you know how to interpret the values, is a very consistent way to get a limit without fail. All right, next one. What is the value of the limit of x approaches 3 of x squared minus 3x plus 7? Well, in this case, I can just plug it in. 3 squared minus 3 times 3 plus 7 is 9 minus 9. 9 minus 9 is 0. 0 plus 7 is 7. Answer is B, 7. Hopefully you can do that quickly. If you really want to be sure, you can go to your y equals x squared minus 3x plus 7 second table set. We're looking at the table start when x approaches 3. Have the change in table. Let's just do 0.1. Look at that table. When x is 3, y is 7. Limits equal to 7. 19. What is the approximate measure of angle x in the triangle below? This is a law of cosine problems. 10 squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of x. 10 squared is 100, minus 25 minus 36 is equal to negative 60 times the cosine of x. So evaluate this. 39 is equal to negative 60 times the cosine of x. You can always double check this in your calculator. 39 over negative 60 is equal to the cosine of x. So negative 0.65 is equal to the cosine of x. So the inverse cosine of negative 0.65 is going to be 130.54. The mode has to be degrees because our answer choice is in degrees, so we need to evaluate in degrees. So the answer is choice D. 130.5 is closest to our answer of 130.54, so we'll go with it. Question number 20. The temperature in degrees F of water in large fish tank. Hint, hint. This was on your packet to end all packets. is modeled by the function t of x is equal to ln of 1 plus x plus 52.4, where x is the number of pebbles in the tank. Approximately how many pebbles are in the tank if the water is equal to 58.3? You set the temperature equal to 50.8.3 and set it equal to the function. Subtract each side by 52.4. Use your calculator, notice, or your head, and notice that 5.9 is equal to ln of 1 plus x. At this point, in order to isolate the variable within the natural logarithmic function, you have to convert the logarithmic function to an exponential function in order to isolate our variable. So we know the definition of the logarithm to know that e to the 5.9 power, because ln is log base e, is equal to 1 plus x. So this is just something we know, a conversion we have to know how to do. And then say x is equal to e to the 5.9 minus 1. In our calculator, we evaluate e to the 5.9 minus 1. That's going to be equal to 364.03. That's approximately 360. Our question tells us to approximate, so A is 360. So will you choose answer choice A? A series is shown below. We have 1, 2/5, 4 25ths, 8 over 1 25ths, and hopefully you can see the pattern that the numerator gets multiplied by 2 each time, and the denominator gets multiplied by 5 each time. So this is 1 over 1 plus 1 over 1 times 2/5 plus 1 over 1 times 2/5 times 2/5, which is 1 over 1 times 2/5 squared. The next one is 1 over 1 times 2/5 times 2/5 times 2/5, or 1 over 1 over 2/5 cubed, because 2 cubed is 8 and 5 cubed is 125. So hopefully you can see that pattern. Well, what is true about the sum of the series? From our formula sheet, s is equal to a1 over 1 minus r. a1 is equal to 1 because our first term in the sequence is 1. r is equal to 2/5 because you multiply 1 by 2/5 for each to get each next term in the sequence. So now s is equal to 1 over 1 minus 2/5. 1 minus 2/5 is 3/5. So s is equal to 1 over 3/5. 1 over 3/5 is going to flip the numerator and denominator of our denominator fraction. So s is equal to 5/3. That's option choice C. So hopefully you can look at the series, find r, find a1, know the series formula, which is on your formula sheet, plug it in, and be able to plug it in correctly. This should be a give me. If you see this question, you say, yes, easy getting this one right. 22 and 23. So we have 2 more problems to go, and then I am out of this school at 6 o'clock. Or later. Actually, it's later. So x is equal to 5 cosine of t plus 3. Y is equal to 5 sine of t minus 1. So x minus 3 over 5 is equal to the cosine of t. Y plus 1 over 5 is equal to the sine of t. So the sine squared of t plus the cosine squared of t is equal to 1. Y plus 1 squared over 5 squared is equal, plus x minus 3 over 5 squared is equal to 1. So here, let's break this down. I'm going a little too fast. So for a parametric equation, finding a circle, the first thing I want to do is subtract each side by 3. Then after that, I divide by 5. That isolates our cosine term. Then I isolate the sine term by adding 1 to each side and dividing by 5. So I'm using the algebra I need to isolate the trig term. Then I use the trigonometry term, sine squared of t plus the cosine squared of t is equal to 1. And so I have y plus 1 over 5 squared plus x minus 3 over 5. So y plus 1 over 5 squared plus x minus 3 over 5 squared is equal to 1. I evaluate each parentheses. Y plus 1 squared is in the numerator. 25 is 5 squared. Plus x minus 3 squared over 25 is equal to 1 times 25. Multiply each side by 25. And get y plus 1 squared plus x minus 3 squared is equal to 25. So the 25 is going to cancel out. So get y plus 1 squared plus x minus 3 squared is equal to 25. Here, this is the standard form of a circle. Y is negative 1. X is 3. So our x coordinate comes first. We have 3, negative 1. Because we switch the signs here. So x minus 3 becomes our x term is positive 3. Y plus 1 becomes our y term becomes negative 1. So that's option choice C. Also, you can graph this parametrically. So you can go to mode, parametric x is equal to 5 cosine of t plus 3, and y is equal to 5 sine of t minus 1, graph that, zoom standard. And you can kind of see that out of the answer choices, the true center, it's going to be 3, negative 1, because the circle's more downward than upward. So 3, negative 1 is the best option. So you could also graph it parametrically, but be careful. You got to be able to interpret this circle. All right, 23, last question. The polar coordinates are 6, 4 pi over 3, or the rectangular coordinates. So we have to know x is r cosine of theta, y is r sine theta of theta. So let's evaluate x first. So the radius is 6, theta is 4 pi over 3, so 6 times the cosine of 4 pi over 3 in radian mode is negative 3. So negative 3 lets us eliminate a and b, and giving us option in c back, so that says eliminate 2c and d. So now we just need to find y. Y is equal to r sine of theta. 6 times the sine of 4 pi over 3 is negative 5.19, evaluating our calculator. Well, the only y value that's negative is in option choice C, so we know that's C. And also, double checking your calculator, negative 5.19 is equal to negative 3 root 3. That is a given solution to every single question in our mock NCFE. So, good hunting on your test corrections. Have a great day.